Welcome to Zombies and Reinforcement Learning Part 8. So we've hit a critical milestone here. In Part 8, we're going to go ahead and start converting this game over to something that an AI can play. That's going to be, turning it into a compatible OpenAI gym interface. Something I meant to say in the last video, if you have questions, if you want to talk about AI or reinforcement learning or robots or any of the other fun stuff, I do have a Discord. I will put that down in the video description. You're welcome to come join and talk about and ask questions about the videos and, generally hang out with tech people. So let's go ahead and get started here. First thing I'm going to do, I'm going to go ahead and commit this to git latest working game. All right. And then I am going to come out of this, and something I suggested in the last video, and I'm going to repeat it again. This is a great time to go ahead and make a copy of the project. So, we've created something that a human can play. It's functional. And we need to go ahead and we're going to start making some pretty substantial changes to make it something that an AI can comfortably play. So if you want to keep the human playable version and keep it functional, go ahead and start work on this next phase on a different copy of the project. So, if you're comfortable with Git, feel free to go stash it in a branch or something, or tag it. If you're not, copy it to a second version. I'm going to go ahead and call this Zombie Shooter V1 AI. And that is the version we're going to be playing with from here on out. So goodbye, original Zombie Shooter project. You will be missed. And just a reminder, at this point in the course, you should have a fully functional zombie game that you as a human can go play. So I am just going to go and open up the other copy of this project. And we can start working on it. All right. So the first thing we're going to do, so let's talk conceptually about what we need to do before we start coding it. So right now we have a main function that has a game loop that's just running game.step with no params. We want to be able to pass in, if you haven't worked with OpenAI gym environments, they have a step method. So they have a step method that takes an action, and that step method is going to return it's going to return state. Let's see, I should have this memorized. All right, that is going to return state or observation, reward, done, and info. And then there's another parameter that we almost never use. So you're going to end up with something like this. It's also going to need an env.reset function. And that env reset function is just going to return state and info, and it doesn't take any parameters. And that's going to basically start the game over. So we need the ability to pass a step into our game, and then we need the ability to, get data back from it. We need some pre-processing capabilities. So we need the ability to go and, take images, take image data, and turn it into something that's, we can feed to the AI. So there are a few different things we've got to do here. But conceptually, let's just start. I think the first thing we need to do is to be able to interact with the game from outside. So we can't deal with, you know, Pygame events in the game loop. Our AI player isn't going to understand how to work with those. So we need, in our step method, if I can find it, here we go. We need to be able to take a parameter that that contains all of this data and turn it into, in this case, a numerical representation. So let's go ahead and for now, what we're going to do in our main.py is we're going to make our main.py sort of the human interface for the machine playable game. So let's start there. So we need to grab this entire block in step. And copy it. And you're going to come over here to main.py, and in the loop, we're just going to go ahead and paste. And it is way too far over. Let's see. We want to pull that for statement, and then let's go ahead and import Pygame, import sys. Okay, and then this will all go. You don't have to worry about that just yet. So over here, we're going to go ahead and delete. To do, add inputs. We're also going to go ahead and grab our keys get pressed. Okay, we're going to need that over here. And we can remove it here. And then we're going to need our, this one's probably easier to just go ahead and type out a little bit. So over here, under keys get pressed, we're going to, first off, up at the top, go ahead and do action equals 0. So we're starting out with an action of 0. We are, the pygame.quit we can keep. That's fine. So in here, we're actually going to give our actions numbers. And you could do this a few different ways. This is how we're doing it for this one. So we're going to say if event.key equals ktab, then action equals 5. If event.key equals k space, and get rid of all this logic, then action equals 6. If event.key equals k escape, then action equals 7. And we're going to come down here and say if action is still 0, so basically if none of these other things triggered, then we want to check the rest of the keys. So we want pygame.kw, action equals 1, and this is getting our movement. We don't want to get rid of a, you know, like a fire command in place of a movement command. And you'll notice that as a human, this will feel a little bit less smooth to play. It definitely will be, but it makes it a lot easier for your autonomous agent to get in there and do its thing. 3 if keys pygame.k pygame.kd, then action equals 4. All right, and then at this point, we now have all of our actions set up, and we can pass in a action equals action. All right. So let's come over here and go ahead and start to set up our game to be what it needs to be. So we actually don't need self.pause anymore. I don't believe we need player moved. Let's see. I don't think we need it. We do still need the length. Oh, never mind. We need our self.paused. We'll keep that. We don't need this stuff. All right. So we're going to go ahead and do some action mapping. And we could just go based on numbers through the whole thing, but I find this a lot easier to read and work with long term. So we're going to say up equals true if action, oh, we need to take an action here. Action, there we go. Up equals true if action is 1, else false. And just copy that a few times. Down equals true if action is 2. Left equals true if action is 3. Right equals true if action is 4. Switch gun. And I'm going to leave this as an exercise for you to, work with on your own if you'd like to. I actually found that including the ability to switch guns made the game far too complicated for the AI to play. It was never able to fully understand that once you switched into shotgun, you would eventually run out of ammo, and that you could no longer, shoot at things. And that resulted in a sporadic, confused training pattern, because it would lose. It almost felt like it was losing the ability to recognize that firing a bullet at a zombie was good, because sometimes when it took that fire action, it didn't actually make it all the way through because it had run out of ammo, and it wasn't smart enough to figure that out. So I'm going to set this to false statically for the remainder of this course. This is definitely, though, like I primarily made this video series to talk about creating custom environments. And I simplified it to get it working. You could probably use something more advanced than double Q learning and get around this. So there's a future exploration for you. So I'm going to say fire equals true if action equals 6. This would be action 5. So we're basically nulling out action 5 on purpose. And we're just setting pause equals false statically. Okay, so pause will always be false. All right. So let's go ahead and let's see. We can get rid of. All right, we actually don't want to get rid of the self.player_speed stuff. So let's go back. Let's see. Well, I'm going to save this. And I think I deleted one more thing than we needed to. This is the lovely thing about having all this in Git. I'm just going to revert that block because we do still need it. And that should be good. We don't need it in its current form, but it's going to be a lot easier to, go back and fix this way. So instead of, keys KA, we're going to say if left. Instead of keys KD, we're going to say if right. If keys KW, we're going to say if up. If down. Simple enough, right? And let's go ahead and see, we haven't coded everything, but let's go ahead and see if this basic functionality
One of those things got
working.
in, kill it!
Okay, so I can move around successfully. I can't shoot anything, but I can move. Okay, so we're making progress. Let's see. Let's go over to our game again. And what I want to find is all right, I think I removed, let's go back over to Git and see if I pulled the fire section. I don't think I did. All right, so this falls firmly under, I was looking straight at it and didn't see it. So our fire logic was here. So we're just going to go ahead and retype some of that. So back down here under step, because it is going to be a little bit different. So we're going to need a variable up at the top that's self.last bullet frame. So let's go ahead up here and we're going to say self.last bullet frame equals 0. So why are we doing that? Well, a human has some physical limits to how fast they can fire a single button in a game. The AI really doesn't. So if the game can run at, say, 60 frames per second, the AI has no problem running, firing 60 bullets per second, one per frame, which is a great strategy for winning, but it does kind of defeat some of the game mechanics we're trying to get here. I don't just want the AI to be able to fill the entire screen with bullets in all directions and that be how it wins. So what we're going to do is we're going to say if fire and self dot, you know what, we also need a total frames. We'll get there. We'll start with 0 for both of those. Okay, so we're going to say if fire and self.total frames minus self.last bullet frame is greater than 10. And then we'll say if self.gun type is single, self.fire single bullet, else self.fire shotgun bullet. And then down here, we'll go ahead and say self.last bullet frame equals self.total frames. And then we will also need, we kind of statically coded the switch gun to false, but let's go ahead and add the logic if you want to change that later. So we're going to say if switch gun self.gun type equals single, if self.gun type equals shotgun, else shotgun. Okay. So okay. One of the things we're going to need to do is go ahead and add a human option or a human variable to our zombie shooter here. So we're going to default to human equals false. Okay. And then we can do, and we're going to start to change certain things based on whether a human's playing. So self.human equals human. Okay. Now let's go down to Pygame. Let's see. We're going to need to change our clock tick. So that's going to be towards the very bottom. So what we're doing here is we're going to say if self.human, then self.clockTick is self.fps, which we passed in as, say, 60. Else, we just want self.clock.tick, which will basically make the game run as fast as possible. So over here, we're going to go ahead and say human equals true, because we as the human are playing the game. Human equals true. But what I was looking for was actually where we're setting total frames. So give me just a moment to find that. Okay, so in the very beginning of the step method, we're going to go ahead, before we do anything else, we're going to set self.total frames plus equals 1. All right, let's go test this out. We should, at this point, be able to
One of those
fire.
things got in. Kill it.
All right, so we now have a step interface that is successfully allowing us to interact with our game. All right, let's go ahead and one of the things we need to do is make sure that disabling sound works across the board. We do not want to engage the audio system when we're playing the game as fast as possible. So let's go ahead and we're going to start by just making not human a shortcut for no sound. So we said sound equals sound, human equals human. We're actually going to change some of that logic just a little bit. We're going to say if self.human, then self.sound equals sound, else self.sound equals false. Okay.
One of those things got in. Kill it.
Okay. Didn't quite, because we played it as human. I am going to change this to human. Oh, that's already defaulting to false. Let's go over here to main, and we're going to change human here to false. Now it's probably going to go really fast. Let's see. Yep. So this is how the AI would play it. By the way, this is what it, you know. And we lost. But you notice it failed out because it said no attribute shotgun blast. And it did that because we probably don't have the right logic around. Yeah, we don't have a if self.sound. Okay, let's just go look for all of the other instances of play. Let's do a better search. Play. Okay, so we want to go ahead and say if self.sound. Okay, that's already wrapped in the self.sound. Okay, so we want this to have a if self.sound. Okay. All of that. Yep, this needs so basically just go through and, or you know what, I think we've already got that logic in play walking sound because I didn't hear a walking sound earlier. So let's go run main again. All right, zombie snarl apparently. And you'll notice I'm just basing it off the error. Zombie snarl. Oh, it helps if I'm in game. Okay. If self.sound. All right, and let's try that one more time. Hey, and we seem to have no sounds. All right, I'm going to say that's a really good place to end this video. We're getting close to the 30-minute mark. In the next video, we'll start talking about processing observations and actually getting data back from the environment. But at least now you have an environment that you can work with externally. So until next time.